I'll continue the previous class topic in this class also. The wave equation for vector H in a perfect dielectric medium is del square vector H is equal to mu epsilon dou square vector H by dou t square. Following the procedure explained earlier, we find that Hz, a function of x comma t, is equal to Hm plus cos omega t minus beta x plus Hm minus cos omega t plus beta x. So what is important is wave is traveling in the plane wave is traveling in the x direction. Correct? Its electric field is in y direction. Magnetic field is in z direction. Electric and magnetic fields are orthogonal to the direction of propagation. The phases of vector A and vector H remain constant as explained previously. Here also you see this is forward traveling wave. So as t increases, x increases, omega t minus beta x remains constant. This is backward traveling wave. As t increases, x decreases, therefore omega t plus beta x again remains constant. Next is phase velocity. Phase velocity. The velocity with which the phase of a plane wave propagates is called phase velocity. For a forward traveling wave, the phase omega t minus beta x is a constant. That is omega t minus beta x is equal to m1, where m1 is some constant. Differentiating, this is the phase, differentiating with respect to t gives omega minus beta into dx by dt is equal to 0. This implies omega minus beta into u is equal to 0. This implies u is equal to omega by beta. What is beta? Beta is what? Omega into root of mu epsilon. So equals 1 over root of mu epsilon. This implies u is equal to 1 over root of, what is mu? Mu naught into mu r. What is epsilon? Epsilon naught into epsilon r. This is like 1 over root of mu naught epsilon naught into 1 over root of mu r epsilon r. If you substitute mu naught equals 4 pi into 10 to the power minus 7 and epsilon naught equals 8.854 into 10 to the power minus 12, you will get velocity of light 3 into 10 to the power 8 divided by root of mu r into epsilon r meters per second. This is the phase velocity of a forward traveling wave. So the velocity with which the phase of the plane wave propagates is called phase velocity. For a backward traveling wave, omega t plus beta x is equal to m2, where m2 equals some constant, differentiating with respect to t gives omega plus beta into dx by dt is equal to 0. This implies omega plus beta into u is equal to 0. This implies u is equal to minus omega by beta. Correct? Meters per second. The negative sign arises because of the fact that backward traveling wave is traveling in the negative x direction. So with this we conclude phase velocity. Next I will go for relation between vector E and vector H. Relation between vector E and vector H in a lossless medium. Lossless medium means perfect dielectric medium. Lossless medium means perfect dielectric medium. The Maxwell's equation derived from Faraday, Lenz's law is del cross vector E is equal to minus vector dou V by dou T. This implies del cross vector E is equal to minus mu vector dou H by dou T because vector B is equal to mu into vector H. We will expand this. We will expand del cross E. So determinant Ax cap, Ay cap, Az cap, dou by dou x, dou by dou y, dou by dou z, Ex, Ey, Ez is equal to minus mu dou by dou d. Vector H is what? Hx into Ax cap plus Hy into Ay cap plus Hz into Az cap. Let us assume that the uniform plane wave is propagating in x direction. Then dou by dou y equals 0 and dou by dou z is equal to 0. Then why? Because vector E is a pure function of x only, because vector E is a function of x only. Also, for a uniform plane wave propagating in x direction, Ex is equal to 0 and Hx is equal to 0. Ex is equal to 0, Hx is equal to 0. Okay. We shall further assume only Ey and Hz are present. Why Ex is equal to 0 and Hx is equal to 0? Because there is no component of vector E and vector H in the direction of propagation. So I have further assumed only Ey is present, that means Ez is 0, and here only Hz is present, that means Hy is 0. So what happens to equation 1? What happens to equation 1? So I will write now. Consequently, equation 1 reduces to this I will write as 0.1, this I will write as 0.2. This is because of 0.1 and 0.2 because of uniform plane wave is propagating in x direction. Okay. Consequently, equation 1 reduces to determinant Ax cap, Ay cap, Az cap, dou by dou x 0, 0, 0, Ey 0 is equal to minus mu dou Hz by dou t into Az cap. This implies dou Ey by dou x into Az cap equals minus mu dou Hz by dou t into Az cap. This implies dou Ey by dou x is equal to minus mu times dou Hz by dou t. This I call equation 2. We know that Ey is equal to Em plus cos omega t minus beta x plus Em minus cos omega t plus beta x. Hence, dou Ey by dou t is equal to, you differentiate this, dou Ey by dou x is equal to, differentiate with respect to x. Cos, if you differentiate, you get minus sign, minus Em plus sin omega t minus beta x into minus beta minus Em minus sin omega t plus beta x into beta. This I call equation 3. Substituting equation 3 in equation 2 gives minus mu into dou Hz by dou t is equal to is equal to beta into Em plus sine of omega t minus beta x minus beta into Em minus sine of omega t plus beta x. Integrating with respect to t gives minus mu into hz is equal to, if you integrate sine you get minus cos, so minus beta into Em plus cos omega t minus beta x divided by omega minus beta in minus of minus it becomes plus beta into Em minus sine becomes cos omega t plus beta x divided by omega. This implies hz equal to hz, a function of x comma t is equal to, divide both sides by mu, so minus mu, so you get beta divided by omega into mu Em plus cos omega t minus beta x minus beta divided by omega into mu into Em minus cos omega t plus beta x. Comparing the above equation with hz, a function of x comma t is equal to hm plus cos omega t minus beta x plus hm minus cos of omega t plus beta x gives hm plus is equal to beta into omega into mu Em plus, and which implies Em plus divided by hm plus. What is the unit of E? Volts per meter. What is the unit of hm plus? Amperes per meter. So volts by amps means impedance, ohms. So equals what? Equals eta is equal to beta divided by omega into mu. What is beta? Omega into root of mu epsilon by omega into mu equals root of equals 1 minute. Hm plus should get multiplied by this is omega into mu by beta. What is beta? Omega into root of mu epsilon equals root of mu by epsilon. Here eta is called as intrinsic impedance of the medium. And what is hm minus? Hm minus is what? Minus beta divided by omega into mu into Em minus. This implies Em minus divided by hm minus is equal to minus eta. Is equal to, what is that? Is equal to what? Minus beta divided by omega into mu. 1 minute. Minus omega into mu divided by beta. Hm minus is equal to this term. Correct? So from here, if you calculate Em minus divided by hm minus, you get minus omega into mu divided by beta equals minus eta, where eta is called, where eta equals intrinsic impedance of the medium. That means this is the impedance offered by the medium to a propagating plane wave in a lossless medium. Note, eta is equal to root of mu by epsilon. What is mu? Mu naught into mu r. What is epsilon? Epsilon naught into epsilon r equals root of mu naught by epsilon naught into root of mu r by epsilon r. So root of mu naught by epsilon naught is 377 into root of mu r by epsilon r. For free space, mu r equals 1 and epsilon r equals 1. Hence, eta equals eta naught is equal to 377 ohms or 120 pi ohms. This is the impedance offered by free space to a propagating plane wave. In which medium? Lossless medium or a perfect dielectric medium. Next, important points. First one, for a forward traveling wave, Ey, a function of x comma t is equal to Em plus cos omega t minus beta x. Hz, a function of x comma t is equal to Hm plus cos omega t minus beta x. Let me sketch the forward traveling wave for time being fixed. This is Ey. What I shown in red is Hz. What is this amplitude? This amplitude is Em plus. What is this amplitude? Hm plus. What is Hm plus? Hm plus is equal to Hm plus equals Em plus divided by eta. Em plus divided by eta. See, this figure is drawn for t being fixed. For example, let us take t equal to 0. Then Ey is a function of x only. Hz is a function of x only. This is for a fixed time. These are the variations of electric field is varying in which direction? Electric field is varying in y direction. Correspondingly, the magnetic field will be varying in z direction. This is plot of Ey and Hz for a fixed time. See, for example, this could be, you focus on this point. At t equal to 0, this point is here. At t equal to 1 second, this point will move to right. T equal to 2, this point will further move to right. Therefore, this is a traveling wave. That means a point on the wave travels in the direction of propagation as t increases. So this is how Ey and Hz are plotted. Ey, a function of x comma t is simply written as Ey. Hz, a function of x comma t is simply written as Hz. This is for a fixed time, means time being frozen. Please keep this in mind. Second one, for a backward traveling wave, Ey, a function of x comma t is equal to Em minus cos of omega t plus beta x. Hz, a function of x comma t is equal to Hm minus cos of omega t plus beta x. What is Hm minus? Minus of Em minus divided by eta cos of omega t plus beta x. Please note that Em plus divided by Hm plus is equal to eta. Em minus divided by Hm minus is equal to minus eta. This you have to note. For a perfect dielectric medium, beta is equal to omega into root of mu epsilon. For a perfect dielectric medium, velocity of propagation u is equal to omega by theta. U is equal to omega by beta is equal to 1 over root of mu epsilon is equal to 3 into 10 to the power 8 divided by root of mu r into epsilon r. What is wavelength? Wavelength lambda. Wavelength lambda is equal to 2 pi divided by beta. Next, intrinsic impedance of a lossless medium. Lossless means perfect dielectric medium. Of a lossless medium is eta is equal to 377 root of mu r divided by epsilon r ohms. This velocity is in meters per second. These important relationships you must remember for doing problems. Thank you. Uniform plane wave propagating the perfect dielectric medium. Perfect is a very important word, lossless it means. Has E is equal to, vector E is equal to 500 cos 10 to the power 7 into t minus beta z. Vector H is equal to 1.1 cos 10 to the power 7 into t minus beta z. Now solution. Before that, if the wave is traveling with a velocity u is equal to 0.5 times velocity of light, find epsilon r, mu r, beta, lambda and eta. Again I repeat. A uniform plane wave propagating in a perfect dielectric medium has vector E equals 500 cos 10 to the power 7 into t minus beta z into ax cap volts per meter, and vector H is equal to 1.1 cos 10 to the power 7 into t minus beta z ay cap amperes per meter. If the wave is traveling with a velocity u is equal to 0.5 meters per second, find epsilon r, mu r, beta, lambda and eta. Very, very important problem. Solution. The arguments of vector E and vector H is, argument means phase. Instead of argument I'll write phase. The phases of vector E and vector H is, the phase of vector E and vector H is 10 to the power 7 into t minus beta z implies the phase of vector equal to 10 to the power 7 into t minus beta z implies that the uniform plane wave is propagating in the positive z direction. Why? Because of the z, it's a pure function of z. Therefore, it's propagating in z direction. The minus sign here indicates that it is propagating in the positive z direction. Also, E is in which direction? X direction. Also, what is Ex? Ex is equal to 500 cos 10 to the power 7 into t minus beta into z. And what is Hy? Hy is equal to Hy because the coefficient of Ay cap is Hy equals 1.1 cos 10 to the power 7 into t minus beta z. This is nothing but Hm plus is 1.1, Em plus is 500. So what is eta? Eta is equal to Em plus divided by Hm plus is equal to 500 by 1.1 ohms. Also, eta is equal to 377 into root of mu r by epsilon r. This implies 377 into root of mu r by epsilon r equals 500 divided by 1.1. This is equation 1. Given u is equal to 0.5 times velocity of given velocity of propagation u equals 0.5 into 3 into 10 to the power 8 meters per second. Also, u is equal to 3 into 10 to the power 8 by root of mu r into epsilon r. This implies 0.5 into 3 into 10 to the power 8 is equal to 3 into 10 to the power 8 by root of mu r into epsilon r. This implies 1 over root of mu r into epsilon r is equal to 0.5. Equation 2. Solving 1 and 2 gives mu r is equal to 2.4 and epsilon r is equal to 1.66. Please check the answers. Mu r and epsilon r are dimensionless. So mu r and epsilon r we have found. Next we have to find beta. What is the expression for beta? Beta is equal to omega into root of mu epsilon. What is mu epsilon? What is mu? Mu naught into mu r. What is epsilon? Epsilon naught into epsilon r. What is omega here? Omega is 10 to the power 7. This is omega. So 10 to the power 7 into mu naught is 4 pi into 10 to the power minus 7. Mu r we have found it as 2.4. Epsilon naught is what? 8.854 10 to the power minus 12. Epsilon r is 1.66. If you substitute the values, you will get the answer as 0.067 radians per meter. Beta is solved. What is lambda? Lambda is 2 pi by beta. 2 pi by beta is what? 0.067. 2 pi by 0.067 gives you 93.73 meters. Earlier, what is the expression for eta? Eta was 500 divided by 1.1. This answer is 453.44 ohms. Alternatively, you can find alternative eta as 377 into root of mu r by epsilon r. Mu r is 2.4, epsilon r is 1.66. If you substitute, you should get the same answer. 500 is nothing but Em plus. What is 1.1? Hm plus. This is how the problem is done. Problem is quite straightforward. Yeah, most of the problems will be of this nature in the examination. Thank you. Next problem. if the electric field vector in free space is vector E is equal to 800 cos 10 to the power 8t minus beta y az cap volts per meter, find the following. Beta lambda vector h at the point x 1.1, y 1.5, z 0.4, t 8 nanoseconds. Examination problem. These are all the exercise problems of the prescribed textbooks, Hyde Junior and Buck. These are very important problems. Problems will be very simple. Derivations require a lot of practice. Please do it. And this subject is a very important subject for studying antenna engineering, microwave engineering, RF engineering. Okay. Solution. So what is, see here, the wave is propagating in which direction? The wave is propagating in the y direction because vector E is a pure function of y. The minus sign indicates that the wave is propagating in the positive y direction. So I see, note the phase of vector E is equal to 10 to the power 8 into t minus beta into y implies that the uniform plane wave is propagating in the positive y direction. What is Ez? Coefficient of Az cap is Ez. Ez is equal to what? 800 cos 10 to the power 8 into t minus beta into y. So many volts per meter. So this is nothing but omega. So first we have to find beta. Beta is equal to omega into root of mu into epsilon. Free space. For free space, mu r is 1, epsilon r is 1. So omega is 10 to the power 8 into root of mu naught into mu r into epsilon naught into epsilon r is equal to 10 to the power 8 into root of mu naught into epsilon naught. Root of mu naught into epsilon naught is 1 over velocity of light. So you get 1 by 3 radians per meter. This is how the problem is done. See, root of mu naught into epsilon naught means root of 4 pi into 10 to the power minus 7. Epsilon naught is 8.854 into 10 to the power minus 12. So this is nothing but 1 over 3 into 10 to the power 8. So this is how beta is found. After beta is found, we will go to lambda calculation. What is lambda? Lambda is equal to 2 pi by beta. 2 pi divided by beta is 1 by 3. So it is 6 pi meters. Next is vector h. Vector h at the point x is equal, at the point, what is the value of y? Y is equal to 1.5 and t is equal to 8 nanoseconds is equal to vector h we have to calculate. What is vector h? To find vector h, see, I'll just make a comment, then we'll do the calculation. The wave is propagating the uniform plane wave. UP means uniform plane. Uniform plane wave is propagating in the positive y direction. The electric field is in z direction, and hence magnetic MF means magnetic field should be in x direction. This is because vector E and vector H are orthogonal to each other. Vector E and vector H are orthogonal to each other and to the direction of propagation. Direction of propagation. Therefore, vector h is equal to hm plus cos of 10 to the power 8 into t minus beta into y into ax cap is equal to what is hm plus is em plus divided by eta naught. Eta naught is what? 377 ohms, the impedance of free space. Cos of 10 to the power 8 into t minus what is beta? Beta is 1 by 3. 1 by 3 into y into ax cap. So many amperes per meter. This is the expression for vector h. Next, let us calculate vector h at point P. Hence, vector h at point P is vector h evaluated with y equal to 1.5, t is equal to 8 into 10 to the power minus 9. So in this expression, what is em plus? Em plus is what? Em plus is 800 divided by eta naught. Eta naught is 377. Cos of 10 to the power 8. What is t? 8 into 10 to the power minus 9 minus 1 by 3 into y. Y is 1.5. Whole thing multiplied by ax cap. So this works out to be x and z values do not play a role here because vector E contains only y in its face. So now if you substitute these values and use a calculator, please note calculator must be in the radian mode. Don't forget this because phase is in radians. So if you calculate, you get 2.02 into ax cap amperes per meter. This is the end of the solution. Next problem. A plane wave is propagating in z direction in a dielectric medium of relative permittivity epsilon r equal to 5. The electric field is in x direction and has an RMS value of 0.1 volts per meter. What is the magnitude and direction of the magnetic field? Calculate the frequency of the wave given lambda is equal to 5 meters. Since the plane wave is propagating in the x direction and the electric field is propagating. 1 minute. The plane wave is propagating in z direction and the electric field and vector E is in x direction, comma, it implies vector h should be in the y direction. Please note that vector E and vector h must be orthogonal to each other and to the direction of propagation. The plane wave is propagating in z direction and the electric field is in x direction. Correct? Hence, it implies vector h should be in y direction. So now what is the magnitude direction of magnetic field? So what is the expression for vector E? Vector E is equal to 0.1 into root 2. Root 2 to convert RMS value into maximum value. 0.1 into root 2 is nothing but em plus cos of omega into t minus beta into z into ax cap. This is the expression. What is beta here? Beta is equal to 2 pi by lambda. 2 pi divided by 5 radians per meter. This is the expression for vector h. Hence, vector h is equal to em plus divided by eta cos of omega t minus beta z into ay cap. What is eta here? Eta is 377 into root of mu r by epsilon r. And mu r is not given, it is assumed as 1. So it is 377 into root of 1 by 5. So eta works out to be 168.59. 168.59 ohms. So this is nothing but, I will substitute 0.1 into root 2 divided by 168.59 cos of omega into t minus beta 2 pi by 5 z into ay cap amperes per meter. So this is the solution of part 1. What is the frequency? We know that U is equal to F into lambda. This implies F is equal to U divided by lambda. What is U? U is what? U is 3 into 10 to the power 8 by root of mu r into epsilon r is U into 1 by lambda. So 3 into 10 to the power 8, mu r is 1, epsilon r is given as 5 and lambda is 5. So if you calculate F works out to be 26.83 megahertz. So once you know the expression for F, we can substitute here omega. Hence vector H is equal to 0.1 into root 2 divided by 168.59 cos of 2 pi f. F is 26.83 into 10 to the power 6. 10 to the power 6 into t minus beta. Beta is 2 pi by 3. 2 pi by 5. 2 pi by 5 into z. Whole thing multiplied by ay cap. Ay cap. So many amperes per meter. This is the end of the problem. Thank you.